Painting a portrait of an organism, like for in this video, a reishi mushroom, is much like how the organism's genes work together to create its physical traits. Let's focus on one trait, like the color of the mushroom, and dissect how this color is expressed both genetically and artistically. To begin this painting, what do I need? Well, I need pigments, but I can't make a painting with just pigments. I also need oil. The oil mixes with the pigment to create the paint. Now that I have the pigment in the oil, I can create a beautiful portrait of a mushroom. So how does this relate to the mushroom's genes? Well, let's see. The mushroom has the gene big B, which codes for a reddish-brown color, represented by the genotypes big B, or big B, little b. Then there is the recessive little b genotype, which is a lack of pigment and appears cream-colored. There is another gene, gene A, that when in presence of B synthesizes a purple color. Gene A is epistatic on gene B. It is a protein that allows for proper development of color in a mushroom cap. But it also has an effect on the color, producing a purple pigment when in presence of big B, and having no effect on the genotype of little b, as there is a lack of pigment to react with. When gene A is homozygous little a, there is no reaction between pigments and the cap color appears red. Let's take a look at how these genes associate by illustrating the epistasis pathway of two heterozygous purple reishi mushrooms. As you can see, all 9 genotypes with big A and a big B will be purple. 3 genotypes with homozygous little b and big A will be cream color. The 3 genotypes with homozygous little a and big B will be red. And the double homozygous recessive genotype of little a and little b will be cream colored. Here is another example of an epistasis pathway, but between a purple reishi with the genotype of big A, big B, crossed with a red reishi with a little a, big B, little b. There are 4 genotypes of big A and homozygous big B that express the purple phenotype. There are 4 genotypes of big A heterozygous big B little b that express the purple phenotype as well. Then there are 4 genotypes of homozygous little a, homozygous big B, all which express the reddish color. And the final 4 genotype of big homozygous little a and heterozygous big B little b, which are also red. So now that we have illustrated this, do you know what makes this mushroom color possible? It's epistasis. Just as in painting, you need the pigments and oils together to create paint. For some traits, there needs to be more than 2 different types of genes that come together to create a unique phenotypic expression.